According to the law of conservation of energy, all right, let's take some notes. Do you have your notebook and something to write with? Let's look at the different types of energy: thermal, chemical, electrical, electromagnetic, nuclear, and mechanical. Take a look at the definition for each. I'll give you a few seconds to jot this information down so that you don't forget, or you can simply pause the video until you're finished. Some examples of energy transformations. The first two examples include chemical energy into kinetic energy. Our bodies are kind of like a car. We need fuel so that we can have energy to move. So gasoline and food are both types of chemical energy, and they're converted into kinetic energy for movement. The last example here is kinetic energy being converted into acoustic energy or thermal energy. When the hand hits down on the table, it releases acoustic sound waves, which are energetic waves, as well as thermal energy due to friction. All right, now we're going to look at the two types of mechanical energy. Remember, there's different types of energy. Well, the two types of mechanical energy are KE and PE, kinetic and potential energy. Remember, kinetic energy is the energy of motion. Potential energy is the energy of position. Additionally, you have two types of potential energy, gravitational and elastic potential energy. Those concepts were covered in the last video. And finally, the unit that we use for energy is the Joule, Joule, capital J, not the Juul that is sold at Come and Go. All right, potential energy and kinetic energy. A roller coaster is an excellent example that shows the transformation of PE to KE. Here you have sections A, B, C, and D on the roller coaster. These sections of the roller coaster show how potential energy is converted to kinetic energy and vice versa. Here's another great example of the conservation of energy. It's a pendulum. We did a pendulum lab back at school, if you guys remember. Here you see that the bob is in its highest point of the swing. That's where the potential energy is maximum, at the highest point of the swing before it's released. As the pendulum bob is released, it accelerates downward because of gravity, and at the bottom of the swing, that's where the kinetic energy is maximum. So what we see here is that potential energy is converted to kinetic energy during this free fall motion of the pendulum. Okay, let's try an example practice problem. It says, what is the speed of a basketball when it hits the ground after being dropped from a height of 1 meter? Again, we know that the law of conservation of energy says that PE is equal to KE. Well, according to our formulas, PE is equal to mass times gravity times height. KE is equal to 1/2 the mass times the velocity squared. Since PE is equal to KE, we can say that MGH is equal to 1/2 mv squared. Now, we want to know what is the speed of the basketball as it falls 1 meter. So we're looking for the velocity. Well, we don't know the mass of the object, but it doesn't matter because the mass, since it's on both sides of the equation, it's going to cancel out. So basically we can say gravity times height is equal to 1/2 v squared, where g is gravity, which is 9.8 meters per second squared, and the height is 1 meter. So to solve for the equation, v is equal to the square root of 2 times 9.8 times 1, which is 4.43 meters per second. Okay, here's one last example. It says a ball with a mass of 0.5 kilograms is tossed upward with a kinetic energy of 150 joules. How high does the ball travel? So in this question, we're looking for the height of the ball. How high does it go in the air when you throw it? Remember, the ball has a mass of 0.5 kilograms. Okay, so, all right, how do we solve for the height? Well, it gives us the kinetic energy at 150 joules. We know KE is equal to PE. So if we set the formulas 1/2 mv squared equal to mgh, then we can solve for h. Now, it tells us that the kinetic energy is 150 joules. So we can set the left side of our equation to say 150 joules. Now, the mass is 0.5 kilograms. So we just say 150 joules is equal to 0.5 kilograms times g. Remember, g is gravity, which is 9.8 meters per second squared, times the height, which is x, which is what we're looking for. Okay, to solve, you would just say 150 joules is equal to 0.5 times 9.8, and then 0.5 times 9.8 is 4.9. So you would just divide 150 by 4.9 and you get 30.6 meters, which is the height of the ball as it's thrown upward. Alright guys, that's about it. Thanks for joining me as we explored the conservation of energy. Now it's your turn. You're going to go to Google Classroom and complete today's assignment on the law of conservation. Make sure you've got a calculator handy, and good luck. See you later.